Let's do another example of finding a line, this time in R3. So here's a question. Let's find the parametric equations for the line containing the point 0, 0, 1 and parallel to this vector in R3. So I tried to draw that line here. This is the point 0, 0, 1, and then the line is parallel to the vector 1, 1, 1. So the vector 1, 1, 1 would be the vector you see here. So what are the parametric equations for the red line? Well, here's my answer. The idea is you give instructions for how to start at 0, 0, 0 and land at some arbitrary point on the line. So you start at 0, 0, 0 and move to the point 0, 0, 1. So you get to a single point on your line. Then after that, you move some distance along the line. So you move according to the vector t times 1, 1, 1. So you pick an arbitrary value t and you move some distance of t along parallel to the vector 1, 1, 1. Now this set of instructions, instruction 1 and instruction 2, give you the parametric equations by describing a vector. So these instructions are to move to 0, 0, 1, and then after, travel some distance parallel to the vector 1, 1, 1. So the parametric equations are x is 0 plus t, y is 0 plus t. So x is the first component, y is the second component, and then z would be my third component. In this example, 1 plus t. So there, these are the parametric equations for my line, and t could be any real number. Let's do another example. Let's find the line containing the point 2, 0, 1 and perpendicular to both the vectors 1, 1, 0 and 0, 0, 2. Okay, well, to describe a line, you need two things. You need a point on the line, and you need a parallel vector. So I have the point, that's given to me. To find the parallel vector, I need a vector that's perpendicular to both of these vectors, orthogonal to both of these vectors. That's why the cross product was invented. So to find a vector that's orthogonal or perpendicular to two other vectors, you take the cross product. So a parallel vector to my line, that is the cross product. So 1, 1, 0 cross 0, 0, 2. So I'm going to take the cross product, I hat, j hat, k hat, put 1, 1, 0 in the middle row and 0, 0, 2 in the bottom row. So if I cross off the I hat row and column, I have the determinant 1, 0, 0, 2. That has determinant 2, so 2 I hat. There's a minus sign in the definition of the cross product when I do the middle term. So if I do the middle term, I again get 2. So cross off that row and column, I have a determinant of 2 again. So 2 j hat. And then lastly, if I cross off the k row and column, I have a determinant that's equaling 0. So I don't have a component in the k direction. This is the vector 2, negative 2, 0. So here is my parallel vector to the line. So the line, following the same idea we had up here, has parametric equations given by this vector, the vector 2, 0, 1. This vector says start at 0, 0 and then move to the point on your line, 2, 0, 1. And then after you're on some point in the line, travel parallel to the line, some distance t. So 2, negative 2, 0. The parametric equations, x is 2 plus 2t, y is 0 plus, I guess, negative 2t. And lastly, z is 1 plus 0t. Again, t, any real number. Now, if you look at these parametric equations, you could actually read back the point on the line. So the point on the line is 2, 0, 1. I got that by plugging in t equals 0. And actually, if you plug in any real number, if you plug in t equals 1 or t equals 2, you get points on the line. You can also read off a vector that's parallel to the line. Those are the coefficients in front of t. Okay, definitely get some practice and learn how to write equations for lines.